Question 6. A spring is initially at rest and has an uncompressed length of 1.5 centimeters. When a force of 2.0 newtons is applied to stretch the spring, it stores 0.060 joules of elastic potential energy. What is the new length of the spring after being stretched? This question tests our understanding of elastic potential energy in springs and how this energy relates to the extension of the spring. So, what do we know? We know that elastic potential energy is stored in a spring when it is stretched or compressed, provided the spring remains within its elastic limit. We also know that for a spring obeying Hooke's law, the elastic potential energy stored can be written in terms of the applied force and the extension as E equals 1/2 Fe, where F is the applied force and E is the extension of the spring. Finally, we know that the new length of a stretched spring equals its original length plus the extension. These are the ideas we will be needing. Now, let's put them to work. We begin with the elastic potential energy formula, E equals 1/2 Fe. From the question, we are given E equals 0.060 joules and F equals 2.0 newtons. Substituting these values into the equation gives 0.060 equals 1/2 multiplied by 2.0 multiplied by E. 1/2 multiplied by 2.0 simplifies to 1.0. So the equation becomes 0.060 equals 1.0 times E. Therefore, E equals 0.060 meters. Since the original length is given in centimeters, it is convenient to convert this extension into centimeters. 0.060 meters is equal to 6.0 centimeters. We multiplied by 100. Now we determine the new length of the spring. The original length of the spring is 1.5 centimeters. The new length equals the original length plus the extension. So, L equals 1.5 plus 6.0. This gives 7.5 centimeters. So, the new length of the spring after being stretched is 7.5 centimeters. This is our final answer. What did we do? We started with the equation for elastic potential energy in terms of force and extension. Then, we substituted the given values for the energy and the applied force to calculate the extension of the spring. Finally, we added this extension to the original length of the spring to determine its new stretched length. Here are the main ideas in a nutshell. Elastic potential energy is stored when a material is stretched or compressed within its elastic limit. For a spring, the elastic potential energy is given by E equals 1/2 Fe, where F is the applied force and E is the extension, and the stretched length of the spring is found by adding the extension to the original length.